All right, hello everybody. We can get into operations with complex numbers now. Hopefully you kind of get the little joke here. He has a little imaginary friend, right? Remember, square roots of negative numbers are imaginary numbers. So the square root of -1 is what we're calling I, right? So that was kind of a little funny, little cartoon there, right? All right. Anyways, so again, complex numbers now. Um, just the I itself is the imaginary part, but a complex number consists of a real part and an imaginary part. Um, so a plus bi, okay, where a and b are real numbers. And of course, I again is that square root of -1. So a complex number can have a real part and an imaginary part. Now, just on a side note, if a number, let's say a number is just a real number only, like for example the number 7, okay, that's just a real number. It could be written though as 7 plus, you could have 0i, and the imaginary part just wouldn't be there, okay? Or just the number I itself, right? And an imaginary number I, the real part could be 0. And it could be written in that form up here of a plus bi. So all the real numbers are technically complex numbers too. But just when we write it in that form of a plus bi, that's kind of the standard form, I guess, for a complex number. All right, so we can do some things. We can do some operations, adding, subtracting, multiplying, and dividing of complex numbers. And let's take a look at an example down here. Let's say we want to subtract. We have 5 plus 3i. Okay, so this right here is a complex number, and we're going to subtract a different complex number. Okay, and the good news with these, it works out if you just treat the I kind of like a variable and do the same, algebraic process, it works out. So we have 5 plus 3i. Now we are subtracting, so I'm going to do subtract each of the quantities, kind of distribute that minus sign in there. And then all we're left with now is just combining the like terms. And let's keep it in the correct order where the real part comes first, then the imaginary. So I'm going to combine the 5 and the minus 7 to become -2. And then we have the plus 3i minus 2i. Those would combine to be a plus 1i. Okay, so that would be our answer as a complex number. We just kind of combined the like terms and got a new complex number. Okay, now this thing of powers of I, so this is a little property that's going to be used when we do multiplication and whatnot. But in the previous section, we learned again that I is just equal to the square root of -1. Okay, that was just kind of defined to be the case. It's just something as a way to deal with square roots and negatives. We just have this imaginary unit in there. So then what ends up happening is if we were to square both sides, we would get I squared. And then if you square something under a square root, it just makes the square root go away. So I squared actually just equals -1. Okay, so that's something we can use. That's going to show up in some of these problems as well. And then if we multiply this new blue equation by I again, we get I to the third, and then -1 times I is just -I. Okay, and if we multiply again, imagine multiplying both sides by I again, we would get I to the fourth. And the way to think of the other side here, using this rule here, you can think of I to the fourth is equal to, let me do this on the side here, I to the fourth equals I squared times I squared, right? Just using rules of exponents. And we know I squared is -1. So -1 times -1 means that I to the fourth actually just equals 1. Okay, so these are kind of the ones we need to know, more so just the first two. But sometimes you might see a problem where, let me just do one quick example. It's not a super common type of problem, but let's say they wanted, for example, I to the fifth power, and you had to simplify that for some reason. The trick is, if you know I to the fourth equals 1, okay, you can think of I to the fifth as just I to the fourth times another I, okay, and then basically knowing that this is just 1, it means I to the fifth really just equals I, okay, okay, which again could also be written as the square root of -1. Oops, not a negative on the outside there. But then this pattern just kind of like cycles through again. Okay, I to the fifth would equal this. I to the sixth would be that. I to the seventh. I to the eighth. Just by using that little pattern there. But again, the big ones for us are these over here. Okay, and again, mainly just the first two or three are the ones that seem to show up. So let's use it. Let's kind of see. I know it's a little confusing, but let's take a look at what's going on. So I squared equals -1. Okay, I squared equals negative. Okay, if we want to multiply complex numbers, okay, and simplify, let's see what happens. So we're going to treat these again just like almost treating the I as a variable, and we're just going to go ahead and distribute or kind of FOIL method these out. So we're going to get 8 plus 6i minus 4i, and then we are going to get a minus 3i squared. And we can combine the terms here. So 8, the plus 6i minus 4i is going to become a plus 2i. And we still have the minus 3i squared there. So here's where we're going to use that little confusing pattern from the previous page. So we are going to replace this I squared with -1. So what it's going to do is change the, instead of being minus 3 times -1, it's going to end up becoming a plus 3. Okay, because again, that 3 is getting multiplied by -1. So that, I mean, that minus 3 was getting multiplied by -1. So our final answer, we add the 8 and the 3, so 11 plus 2i. Okay, so as long as you replace the I squared with -1 and then simplify, that's kind of how these work. You don't want to leave it as I squared because again, it is able to be simplified. Okay, let's do another one. So 4 plus 2i times 4 minus 2i. So the 4 times 4 is the 16, right? That's that times that. The 4 times minus 2i is going to be minus 8i. 2i times 4 is plus 8i. And the plus 2i times the minus 2i would be a minus 4i squared. Okay, so what ends up happening here, a couple things. The minus 8i and the plus 8i kind of cancel each other out. Okay, and we have that same situation where we do have an I squared in there, right? So what we really have is that 16 sitting there. It's minus 4 times -1, which makes it plus 4. And so this answer actually equals 20. Okay, so that's kind of introducing something that's going to be helpful for us. This example here, if you look at those terms, I set those up on purpose where they were the same terms, it just one had a plus in the middle and one had a minus in the middle. Okay, those are known as conjugates, or they're a conjugate pair. So like A plus BI and then A minus BI. So all the numbers are the same except again that sign in the middle. And the reason those are going to be helpful for us is that when you multiply conjugates, like we just did in example B, see how those middle terms canceled out? Okay? When that happens, the imaginary terms cancel out, and you always still have that I squared, so you're always going to end up with a real answer, a real number. Okay? It's not going to have an imaginary part like the previous example did. Okay, so keep that in mind. Multiplying by conjugates is a way to get yourself a real answer out of it. We did in this previous example over here, where we took a complex number and we showed when you multiply by its conjugate, you get a real number, don't you? All right, so let's keep that in mind as we do the last operation, which of course is division. And the rule with division, okay, these are kind of weird too. You don't really seem like you're dividing necessarily. The rule is you're kind of more like simplifying, and we want to use those powers of I that we talked about. And one other thing, when you simplify, you cannot leave a I in the denominator. Okay, it's just kind of like a rule, like reducing a fraction. You can't leave imaginary terms in the denominator. Okay, kind of like when we do when you do trig. If you've done some trig, you can't leave an irrational number in the denominator of a fraction. You know, you can't leave it as 2 over square root 2. You need to simplify. It's just kind of one of those things. So what we want to do on these, 10 minus 2i over 5i. And the trick is, again, let's think about a way to make the denominator not have an I in it anymore. Okay, and what we're going to do, just like when you reduce or simplify fractions, you can either divide the top and bottom by the same thing, or you could multiply the top and bottom by the same thing. What we're going to do, we're actually going to multiply the top and bottom of this by I. Okay, and you'll see what's going to happen in just a second. But as long as we do the same thing to the numerator and the denominator, it's going to keep the fraction equal to what it was before. But it's gonna do something for us in the bottom in just a sec. So let's do that. Let's distribute out the numerator. So we're gonna have 10i minus 2i squared. Okay, and the denominator 5i times I is 5i squared. Okay, so let's think about a couple things. We have some I squareds in there, right? We have I squared here and here. So I'm going to replace each of those with -1. Okay, so the numerator is going to become 10i. Instead of -2 times -1, I'm going to write it as +2. And the denominator is 5 times -1, so -5. Okay, and then just to write it in the correct form, we can split this up. Remember, complex form, number form is a plus b times I, right? So we need to write the real part first. I'm going to split this fraction up first, actually, and then we'll worry about that. 10i over -5 plus 2 over -5. And if we want to get it in standard form, I'm going to write this number first, so that's just -2/5. And then this number here is reducible, right? The 10 over 5, of course, can be written as 2 over -1. So this is really a -2i. Okay? Okay, now honestly, the way we had left it up a couple steps previous, like up here, is basically the answer, but just to get it again in that form where it's a real number plus or minus b times I, to get it in that technical standard form, we would need to just simplify it a little bit farther into what we see here. All right, and one more division example here. This one's a little bit different as well. This one now, if you notice compared to the first one we did, the denominator was just a single term. Okay, there was no plus or minus. We call it a monomial, where in example B it's a binomial. Okay, it's a full complex number with an a and a b. So the trick with part B, though, if we want to make the denominator become a real number, right? Remember we said we can't leave any i's in the denominator. The trick with part B is to do what we're going to do. We're going to multiply top and bottom by the conjugate of the denominator, because the denominator is the one that we want to turn real. Okay, so if we do it to the denominator, we need to do the same thing to the numerator. And again, just kind of think ahead what's going to happen. The denominator, 2 plus 3i times 2 minus 3i, since they're conjugates, right, they have different signs, it's going to end up being a real number. Okay, and we'll just simplify some things in the numerator and see what happens. So I'm going to FOIL out the numerator. 4 times 2 is 8. 4 times the minus 3i is minus 12i. Minus 5i times 2. And then minus 5i times minus 3i is plus 15i squared. Okay, and we'll clean that up in a minute. The denominator, let's FOIL that out as well. 2 times 2 is 4. We're going to have 2 times minus 3i, so we're going to have a minus 6i. And then we'll have a plus 6i. Remember, those always cancel out. And then we'll have a minus 9i squared. Okay, and let's start cleaning some things up and see what happens. We do have a couple terms with I squareds in there, right? So we'll take care of those, and we'll combine some like terms as well. So in the numerator, I have an 8. So the minus 12i minus 10i is minus 22i. The plus 15i squared, if we remember that's negative 1, will make the plus 15 become minus 15. All right, the denominator, the minus 6i and the plus 6i cancel out. So we have 4 minus 9 times negative 1 becomes plus 9. Okay, and that's going to leave us in the numerator 8 minus 15 should be negative 7 minus 22i. The denominator is just a real number, equals 13, right? It's not imaginary anymore. That's what we wanted to happen. Okay, so that's actually one way you can write the answer that way. Or to, again, get it in the a plus bi form, we just split up the fraction. Negative 7 over 13 minus 22 over 13. And then, oops, then we have that I there. Okay, and that would be our answer. That's technically the best way to write the answer in standard form. Okay, now there is a way, if you guys have the graphing calculators, there is an I button on there. I'll see if I can get the image in here. And you can do some of this stuff on there. Now I'm going to want to see work. I need you to know how to do the conjugate kind of thing. But, you know, if you're taking a standardized test or something, calculator portion, and you know where that button is, or like I said, I'll try and make a quick addition to the video here for you guys. There is a way to do some of this stuff on there.